Hello, welcome to everyone. In this video, this is our lecture number 5 to solve the question asked in this quantum mechanics. Actually, this is the part 3 of the solution of this book, and rest of the lecture consists of the solution of the problem asked in this SN Ghosal. So if you want to watch the previous lecture, you can go through the description box. Link are given there, and there are various physics related video for theoretical and problem solution are available in this channel. If you want to, you can go through the description box or in the channel physics by Laxmikanta. You will be get different physics related video, right? In this video, I want to discuss question number 19 to 27 of chapter 1, which consists quantum mechanics, that is the foundation of this book, that is the chapter 1 of this book we want to discuss here. So let's start with question number 19, which shows that if the recoil electron in a Compton scattering has very low energy, the change in wavelength of the photon scatter will be like that, where the phi is the angle given by this. So this will be phi, no problem. This problem actually solved in the video for the problem asked in the SN Ghosal book Quantum Mechanics. So if you already watched these things, you will know about these things. Just equating those two things, that is the energy conservation and the momentum conservation, and along x-axis and y-axis, you can easily find out this expression, no problem. Okay, I do not want to repeat these things because we already discussed in the previous lecture during the solution of the SN Ghosal problem solution. Okay, so if there is any problem to understand this thing, you will be comment in the comment box. Before that, you just go through the solution previous lecture. Okay, next question says that the recoil angle of Compton electron will be like that. P is the momentum of recoil electron. Nu theta is the frequency of photon scattered at angle theta to the incident photon of frequency nu. So this is the incident photon and this is the scattered photon with nu theta at angle theta, and this is the phi. Actually, in theoretical there is a written in here when we discuss theoretical part, but here the convention is the opposite. Okay, sorry. So if you taking the energy conservation, so h nu equals to h nu theta plus, this is the new taken nu theta, half m v square. V is the velocity of the electron. So h nu equal to h nu theta plus p square by 2m. Now if you take the conservation of momentum along x-axis, you will be get h nu by c equal to h nu theta by c cos theta plus p cos phi. Okay, this is h nu theta by c along that direction. This is cos, this is sine. So this is along cos theta. For that one also p cos phi. Okay, and along y direction will be get the along that direction. This is sine and this is negative, the minus sign. Okay, sorry. So you will be get these two relations 2 and 3. If you square and 2 and 3 and adding these two things, square and adding 2 and 3, you will be get this relation. Okay, so I think clear about this calculation. I think you understand this calculation very easy. Next question says a photon of energy scattered angle 90. Applying the law of conservation so that the angle theta between the incident photon and the recoil electron satisfy this. So here this angle is 90. You need to find out this theta in terms of in this relation. So you know the quantum sheet will be like that here. This phi is 90, and if you consider the momentum conservation, this momentum is h Newton by c and this is p sin theta. And along that, this is p cos theta and this is h nu by c. So from momentum conservation, you will be get these two relation. P cos theta equal to h nu by c and P sin theta equal to h nu prime by c. And from this relation, lambda equal to cy nu. So this is cy nu prime and this is cy nu. Will we get this one? And at this is 90 cos 90 is 0. So you will be get this relation. So here you can see this in this relation you need to find out this one. Okay, so from energy conservation, this E equal to h nu by h nu prime, energy of recoil electron. Now you can see that is from this relation lambda prime equal to lambda plus this one. Lambda comes into the nu, and so will we get this value of h nu prime. So you will find out the from this h minus h nu minus h nu prime. So you will be get this one. So from relativistic equation you will be get the value. That's one. So this is the value of this one, that is root under 5 by 4. So from equation you will be get this one. Okay, so just verify this calculation. Next one. So that the complex scattering of photon of energy h nu by the electron initially addressed the relation between the scattering angle theta of the photon corresponding nu theta and the recoil angle phi will be like that. Okay, so you will know about this relation from theoretical class, that is cos theta equal to 1 plus I cos pi by 2, but here the notation are different. So that's why theta comes into phi and phi comes into theta, and alpha denoted here beta, no problem. So this relation can be written as like that. Squaring both sides, taking cot square is tan square, and then is will be like that. After that, here you can see here tan square phi into multiply this one, and 1 by tan square is cot square theta by 2. Cot square theta by 2 is cos square theta by 2 minus 1. So cos square theta by 2 is 1 plus beta square tan square phi plus 1. So cos square is 1 by sin square. So this is 2 sin square multiplied with 2, and this is 1 minus cos theta. So cos theta equal to this one. I think clear. Next question. The ionization potential of an atom is 13 volt. What will be the minimum velocity of this? So minimum velocity is kinetic energy is potential energy, minimum velocity is 2 ev by m. Okay, next question. A muon, an unstable elementary particle whose mass is this. This is the mass of muon, and charge is plus e or minus e. The negative muon can capture by a nucleon from a nucleonic mass, and a proton capture mu prime mu minus. Find the radius of Bohr orbit and the ionization energy. So here the conservation, that is the centripetal force and the Coulomb force will be equal, and this MBR equal to NH by 2 pi, that is the Bohr hypothesis. So equating these two things you will be get this relation V, or from this relation you will be get R. So for Bohr radius, that is N equals to 1, you will be get this one. And ionization energy, for ionization energy you will want to find out the energy half mv square. You will put this value of V here, expression of V. Use this expression of V here, you will be get this relation, and putting this value you will be get this one. Okay, next question. Mercury has an ionization potential 4.9 ev. Calculate the wavelength of the radiation radiated when this one. So energy, from energy you can easily find out the wavelength equal to hc by lambda. So lambda is hc by e, h, c and e. Okay, next question. Calculate the velocity, radius, energy of first Bohr orbit, also Rydberg constant. So the same thing here. Here you equating this centripetal force with the Coulomb force, and this force theory. You divided this two, you will be get the velocity. After that, from equation 2, you will be get the value of r, radius, and then energy half mv square. You will be get value of energy. Now Rydberg constant actually, when there was a transition between one energy state to another state, the Rydberg constant arises. So energy equal to this one. From here you will be get this value. Here we miss the n for the first orbit. N is here, so in place of h, here we place the nh. Okay, nh. So that's why this expression consists n, and this n is 1 and infinity. So if you take finally 1 for Rydberg constant, This will be 1097 10 to the 7 meter inverse. Next question. Next question says calculate the energy of first of line of 11 series of this one. I actually did not find this value from this relation. There is a missing of this theoretical part also. So that's why we use this relation, that is the energy of hydrogen, that is minus 13.59 by n square. So n is 2 from 1, so put value 2 from 1, you will be get this one. Next question. The Rydberg constant of hydrogen will be like that. For ionization helium will be like that. This is for hydrogen. This is for helium. This is also discussed in the question series of the SN Gosal. You can also refer to this one. But here you can see that is the relation says that is Rydberg constant at this constant by 1 plus m by m. M is the mass of electron and this is the mass of atom. Okay, so there is two case, hydrogen and there is helium. Now the here says this the helium has 4 times the mass of proton. So in case of proton, when the hydrogen, this is the mass of proton and this is the helium. Helium is a 4 times of mass of proton. So taking this as x, m by m h to take as s, you will be get the value of x, and 1 by x is mh by m, that is the mass of proton with respect to electron. Mass of proton with respect to electron will be find out like that. Okay, so there is a approximation, that's why this not match. If you take this approximation exactly, you can get this answer, no problem. So I think clear. If there is any doubt, you must comment in the comment box. This is all about me and this is my contact detail. You can connect with me. It is Telegram channel. This is my online platform and this is my YouTube channel details. Go to this channel. You will get different physical videos, some mathematics part also. Like this session. If you learn something from this session, share this video to your friends. Either he or she also get benefit from this video. Subscribe this channel if you new in this channel. Please already subscribe. Thanks for subscribing. Press the bell icon to get notification of upcoming videos. So take care. We'll meet in the next video as soon as possible. Thank you.